Hello and welcome to my brief talk on reducing barriers for contributors with GitHub Codespaces at the PyCon Maintainers Summit. My name is Craig Peters. I'm a product manager at GitHub and I work on Codespaces. I'm particularly interested in how open source communities can take advantage of cloud-based compute to make their projects more accessible to much broader audiences. You can find me on the Python Discord at 6625 and on Twitter at PetersCraig. My DMs are open. So I've got a couple of quotes on folks who found Codespaces valuable in a couple of different contexts that I think will help you get some ideas about what I'm trying to convey to you. So first, this guy Kunal was at a conference and was discovering that some people were having challenges with different dependencies causing conflicts in their environments. And he said, look, if you're a developer facing these compatibility issues, you might have low RAM or not enough processor, then you're in luck. GitHub Codespaces is a solution to these kinds of problems when you're working with open source projects with different versions of dependencies. And that highlights a really important attribute of Codespaces, that it's isolated virtual environments that allow you to be doing different work on different projects at the same time and that not have any impact on your local machine. Alex observed that he was using Codespaces to teach Python. And he wrote up this awesome blog about how people come to these learning environments with very different experience, very different kinds of environments and tools, and giving them a pre-configured environment that gets them exactly to the point of learning very quickly eliminates huge amounts of frustration and time wasted just getting people's machines up and running and being able to do the same work. I'm really passionate about this because I believe that open source ways of working, the transparency and inclusiveness of ideas from many different places, together with actually making it possible for the huge portions of the world that today can't actively participate in our open source communities, can really solve much bigger problems. And so we need to be investing in making our communities much more diverse. If you think about the things that are blocking people, these are three, there's lots of course, but three of the ones that I think about all the time are the complexity of the first time experience, the inability to be able to even download or run certain things locally, and not having experience with complex tools like Git. So the READMEs, if you think about our READMEs that we write for our projects all the time, we have to make assumptions about what people are coming to do, what their goals and objectives are, and what they know. And those assumptions make it so that only a subset of people actually have a reasonable experience when they first come to the README. Oftentimes there's a whole lot of research and things people have to do to actually even understand what an open source project's about and how to participate in the community around that. The next is many people who want to contribute only have access to a tablet or a Chromebook. And that access to hardware is really limiting, especially in environments where you have a lot of dependencies that you need to download, and you have processor, memory, or even storage intensive things like builds and test runs that have to be accomplished before you can even make a push into a repository. And then the last bit is that sort of know-how around Git. And we all know how Git can be super friendly for us. I mean, say that very sarcastically. And what is the outcome? The outcome is that you often have a terrible first-time contributor experience, and sometimes that's even after the first time. So what do we have to solve that? Well, we can use these instant on cloud development environments that are secure and available all over the world, and they are declarative. You've got the development environment as code embedded in the project itself so that everybody comes and gets exactly the same experience because you have a configuration at the repo level. It's immediate and it provides effortless onboarding to projects. For maintainers, that's super valuable because you don't have to spend your time maintaining your environment for projects that you only contribute to on a weekly or monthly or even less frequent basis. And we all waste our time doing that. And then you can work anywhere on any device. And because we provide persistence between sessions, your session can time out, and that's just fine. We save all your work, and you can just log back in, we'll mount your storage, and you can continue off where you left off. And then when you're ready to collaborate on your work, you just push that work into a GitHub repo. So let's take a quick look at what that looks like for NumPy. So here I am at the NumPy project. It's an awesome Python project. If you're not, I have to imagine most of you are aware of this project. It's a very sophisticated Python library for doing all kinds of mathematical operations that sits on top of a whole bunch of code that is mostly written in C and C++ to do very efficient memory and processing of these functions. And that means complexity. And so the development environment actually requires a fair amount of setup and maintenance to keep it going. And happily, the NumPy maintainers have actually done the work for us to make it so that we can just create code spaces. So you can use the local clone and keep your machine set up locally to work in the NumPy repository. Or you can use Codespaces, which takes advantage of the configuration as code that's contained in this .dev container folder. We can take a look at that in just a second. But I've actually started a code space right here. And it's reconnecting me using the web client, which is my personal default go-to. A lot of people actually work in VS Code or in other editors. We support the JetBrains editors as well. But I personally prefer just kind of the lightweight, ephemeral experience of working in the code editor. And so I'm going to activate the environment. And you'll see right away I'm in my NumPy dev environment. I didn't have to do any local setup. And if I go and look at the documentation for contributing, I'll be able to see what I need to do next. So say, for example, I want to run install all the dependencies for running tests. I don't have to perform any local setup to be able to just run these commands. And everything's all set up nicely and locally, and my fan is not running. I'm able to record this video, and all of that works just fine. So let's take a little look behind the scenes at the setup itself. So in the dev container, you'll notice for this particular project, there are two files. So dev containers are a container-based technology. The spec for that is actually at this handy URL, containers.dev. And so here you'll see an overview of what dev containers are and reference specification for what they do, so you can understand how all the configuration works. So in the dev container file itself, we'll just take a quick look at that. It's only doing a very little bit of work. So when you create your code space, it's running the setup shell. Actually, the first thing to notice is that it's using our universal image. For Codespaces, this image is actually baked into the VM so that when you start a code space, it has a bunch of tools, including Python and Conda and other things that you might need in order to do your work. The next thing that happens is when you create a code space, it runs these lifecycle scripts. So on create, it's going to run the setup shell script that basically initiates the environment and gets everything set up correctly so that the repo is ready to go when you're there, and then it installs any customizations that you might want. In this case, the maintainers just think that we'll need the Python extension so that when we go edit the Python code, VS Code behaves correctly. And then that means that now I've got this environment where I can do all of my work. I can edit my files in the editor, run my tests, do my build, get everything ready, and make pull requests right from within here. We've got the whole ability to manage the Git interface right within the VS Code web environment. So if I go back to the NumPy repository, you'll see here that I can always view all of my code spaces. And these are all the code spaces that I'm working on. I can see what kind of machines I'm running them on. I can sort them by repository and all kinds of handy things like that. So Codespaces just makes it really easy for me to work on lots of different projects at the same time and flip back and forth between them without having to mess with my local setup. So if we go back here, I've gathered a few handy links for you. So that last link I showed you where I can see all my Codespaces is handily at just github.com/codespaces. We have a nice short URL for the documentation. If you go to github.co without the M /codespaces-help, that'll take you straight to the documentation. The specification for the configuration syntax that I showed you is containers.dev. There's plenty of discussion within the Codespaces documentation as well about how we take advantage of that and what's specific to Codespaces within that spec. And then the community of users who work using Codespaces share information, ask for help and tips from each other, and they work in this discussion board at github.co/Codespaces discussion. And with that, I really hope you'll have a great experience working with Codespaces in your environment. Reach out to me with all your feedback and questions and suggestions for new things. We love to hear from you, and I look forward to talking to you during the Q&A session. Thank you.